today, Facebook, Instagram, they all had outages, and we don't have a postmortem yet or anything, but I do think it would be interesting to look at a previous postmortem from October 5th, 2021. This was a huge outage. It lasted for like a whole day. I think there's some very interesting stuff we can learn from this. Okay, so this was this big October 4th outage, and it was one day later that they came out with this really nice postmortem about just like the whole thing that was going on. My guess is the outage today was likely something similar. It's usually just these big infrastructure configuration changes that cascade out. So now that our platforms are up and running as usual after yesterday's outage, I thought it would be worth sharing a little more detail on what happened and why, blah, blah, blah. This outage was triggered by the system that manages our global backbone network capacity. The backbone is the network Facebook has built to connect all of our computing facilities together, which consists of tens of thousands of miles of fiber optic cables crossing the globe and linking all of our data centers. Okay, let's break that down, because there's definitely some spice to talk about. So they have, a data center here. We'll just call this DC. Maybe this is in Oregon somewhere or something. They'll have these other data centers elsewhere, and these exist, maybe in Washington, DC. And this is global, so maybe we should put this in like Europe somewhere, and this one maybe in Asia somewhere. And these data centers, they have distributed databases, some of the application code and things, and a bunch of stuff that needs to be eventually consistent across all of them. So you end up with, just these massive configurations of, really, it's like a network. It's really like a virtual private cloud you might think of if you're familiar with AWS, but a virtual private cloud that goes across entire data centers and with those services. So what they're talking about with this backbone network, let's just put one of those there. Let's put one of these here. This is what they're talking about when they talk about the backbone network. So those are those backbone networks that connect all those together. These data centers come in different forms. Some are massive buildings that house millions of machines that store data and run the heavy computational loads. So this is, when I say DC here, really what we're talking about. Is, and let's zoom over here, is we're talking about physical machines. These physical machines run probably virtual machines. Those virtual machines are running, data workloads. They're running AI workloads. They're running, everything. If you've ever been in one of these data centers, they are magnificent to behold. They are absolutely wild. They got so much going on in there with all these machines and networking, and this is the physical layer of the compute, the actual compute happening. So when they say our data centers that are connected by these backbone networks, what they're saying is these are like an AWS region. This is the whole kit and caboodle over here. Other smaller facilities, so it's not just the really big ones, but these are all connected by the backbone network to the broader internet and the people using our platforms. So what that is behind the scenes there, and there's probably an additional link here that bridges these backbone networks that connect all the data centers together, and inside of here is likely, and again, I'm much more familiar with AWS terms. So what we end up with is this is essentially a internet gateway, and those internet gateways, those are very, very special components. Those internet gateways allow for all kinds of traffic to come in. This is actually where we have people making requests to Facebook, Instagram, et cetera, that then they can get into this network, be routed to the specific data center, and then that data center has some virtual machines where they're doing actual workloads, and they can handle your actual request. Maybe you're looking for a photo on Instagram, or et cetera. But this is the flow, is I'm making a request from the internet that goes into the internet gateway. They're saying they have this backbone network thing that connects all of their data centers together. That gets routed to a specific data center, which then gets routed to a specific machine, virtual machine, that can handle your actual request. So that's a lot to say for, like 2 very short paragraphs, but that's sort of what they're getting at inside of here. When you open one of our apps and load up your feeder messages, the app's requests for data travels from your device to the nearest facility. That's just classic cloud computing 101. If I was physically in Asia, in this like 3 data center example, if I was physically in Asia, this request would just get routed to this data center because it's physically closest. And this internet gateway, again, this is a lot of like abstraction. It's going to load balance that to the best data center, which usually is the physically closest one. It's kind of wild how, like, at a global scale, you do have to think about your physical data centers, like where these data centers physically are, because that is true latency. The difference between getting routed to something in Oregon versus getting routed to something in Asia, depending on your physical location, could be on the magnitude of several seconds, or even a timeout if your timeout's set to something like 10 seconds or 15 seconds, etc. So this is huge. This is, again, probably mostly handled if you're using something like AWS, just by load balancers you have at the global scale. So that's kind of what they're saying here, is they have this backbone network which handles that global networking there. The data traffic between all these computing facilities is managed by routers. Okay. Again, this is like networking, virtual private cloud, networking stuff 101. Those routers which figure out where to send all the incoming and outgoing data. In the extensive day-to-day work of maintaining this infrastructure, our engineers often need to take part of the backbone offline for maintenance. Okay, so they're taking the backbone network offline for a bit of maintenance, perhaps repairing a fiber line, adding more capacity, or updating the software on the router itself. So this is kind of crazy to think about. Is they're teasing apart some of these layers of abstraction. So let's do that as well. Let's tease apart one of these backbone network layers. What's going on inside of here is actually physical layers of the networking happening all the way down to like fiber cables. So they are talking about this backbone network having routers, which these are really just it's more computers in the end. It's more computers that know and have software installed in them to do routing things or networking things. So let's go over here just so we can draw this out a little bit. These routers have software installed on them, just like any other computer. So if you were going to run like a home lab or something, you might have a few of these routers set up to build yourself the firewall or the various components of your network to then distribute your compute power across different things. So each of these is going to have software, physical hardware, physical networking hardware, physical connections between routers. And this is what builds that whole sort of layer of infrastructure where, I might be a person. Let's just draw a person over here. So I might be a person, and this person is holding their little tiny phone, and they're making a request. Let's say that they're making a request to Instagram.com, or they're trying to look up some photos of their ex or something. I don't know, whatever's on Instagram these days. They're inevitably going to go through the internet gateway into the backbone network, and that backbone network is made up of routers that receive the requests, and they say, okay, I know about, the next layers of, I know about this router or maybe another router over here or something. It's a whole network of these things. And these routers with their software and then the physical layers of the network then get to decide, okay, we're going to route this into here. Okay, this one knows about the next few steps or something, and we're going to route this into here. And then eventually these routers, this backbone network, is going to send it to the actual data center itself. So they're kind of building up an idea of how these enterprise grade networks, not necessarily in a third-party cloud like AWS or GCP, but in their own first-party data centers, they're building up an idea of how this works. So they might at times, need to take a certain router offline to patch the software, to physically replace one of the components of that physical machine, or even repair or replace the physical fiber lines that exist between those machines inside of the data center, or even between data centers. So again, pulling all that apart, it's all turtles all the way down. It's all computers all the way down. And those computers require certain software updates, et cetera, in order to work. So in this scenario, if, say we needed to take down this router just to be able to, do a patch software update or something, in theory, this first router off the internet gateway that we would actually hit, it doesn't just know about one router. That would not be a very well organized network. It knows about many routers that would inevitably give us a path, a roundabout way over here, and it's going through a different router here. Is what I'm showing here. So this is actually going through a different router that it knows about. It knows that this router is offline, so it's giving us the roundabout way to actually get all the way down here to this data center. That's how that's possible. There's no single point of failure within the network. There's always paths. There's always ways to make things work inside of these enterprise grade networks. The most efficient path is probably still the first way it wanted to go, down this way and through here, because it knows about the latency between some of the routes it's trying to take and the best route to go. But in a worst case scenario, it will go this roundabout way over here. This was the source of yesterday's outage. Okay, so now we're getting into the meat and potatoes of it. During one of these routine maintenance jobs, a command was issued with the intention to assess the availability of global backbone capacity, which unintentionally took down all the connections in our backbone network. Yikes. So it took down everything, this one command that was run, effectively disconnecting Facebook data centers globally. So what happened, what they're saying is that they ran some command. Let's zoom out a bit. They ran some command, and it just all of a sudden just completely took down the backbone network, which is the connection between all of these physical data centers in this enterprise grade network. All of a sudden, connections to the internet gateway, and maybe even the internet gateway itself was taken offline. All of a sudden, there's just no routes. There's no actual virtual connections between all of those. And I say virtual connections because the physical fiber lines still existed in the router matrix. These physical connections were still obviously plugged in, but what they're saying is that router A here, this router, all of a sudden didn't know about in its virtual space the network to get over here router C through router B or whatever to the data center. So they ran this command. It brought down the entire backbone network, unintentionally took down all the connections in our backbone network, disconnecting Facebook globally. Our systems are designed to audit commands like these to prevent mistakes like this, but a bug in that audit tool prevented it from properly stopping the command. Okay, so maybe my previous statement was wrong, or it's always configurations. They did have some internal tool or some audit tool of some kind that was meant to catch this kind of problem, this kind of error, but the bug in that audit tool did not catch that and did not prevent this command from blowing over the entire network there. This change caused a complete disconnection of our server connections between our data centers and the internet, and that total loss of connection caused a second issue that made things worse. Okay, so let's imagine what happened here. So some command, some CLI command or something, some command got run, and this command was intended to just do an audit, just assess availability of the backbone network. So it's coming in here, it's looking at the backbone network. What it unintentionally did is it accidentally brought down all connections to the backbone network, disconnecting it globally. And this is where we sort of get to imagine a little bit, because they are being intentionally vague a bit, but we can remove all of these connections now, as it basically brought everything down including, it sounds like, the internet gateway, where now all of a sudden all of these data centers are not connected to each other, and also globally to the wider internet over here. So we could also get rid of backbone network. Now there's just these disparate data centers that aren't connected in any way. This caused a second worse problem. One of the jobs performed by our smaller facilities is to respond to DNS queries. DNS is the address book of the internet, domain name service. You can use it. It's how you go from facebook.com to an actual IP address that then computers can know about and be routed to correctly, et cetera, et cetera. DNS, it's great. Enabling the simple web names we type into browsers to be translated into specific server IP addresses. Jinx just said that. These translation queries are answered by our authoritative name servers that occupy well-known IP addresses themselves, which in turn are advertised to the rest of the internet via another protocol called the Border Gateway Protocol. Okay, so this is getting into some like real gnarly enterprise grade networking technology mumbo jumbo stuff. Let's break it down. Let's break it down some more. Let me bring all this back and paint us the picture of what things should look like. So what they're saying is that inside of here, and let's just grab another data center. Inside of here, connected also to our backbone network, is a well-known DNS server. That well-known DNS address is something like you might see with Google's like 8.8.8.8. That is Google's well-known authoritative DNS server that basically almost anybody can use to resolve domain names into actual IP addresses. So I'm just using 8.8.8.8 as an example because that's the one I know the best. You can think of this as, somebody's going to hit the well-known IP address, and that is well known to other services, internal Facebook services, other apps that they have, etc. And this could be something like facebook.com ? Because facebook.com doesn't actually take you anywhere. We need to look up the actual IP address of that. So what it's going to get routed through to, and this is quickly becoming an explanation of how DNS works. Facebook.com, what is this? My computer doesn't know. We got to go ask a DNS server what that is. And we can use a well-known one to figure that out. Let's change this to 1.2.3.4. Because Facebook's well-known DNS server is not Google, so we don't want to confuse that. But that can get routed through to that, and then on the other end, we can have this get sent out to an actual IP address, and that actual IP address is something like 0.0.99 or something. I don't know. Some address that will resolve to one of these DNS servers that these routers can actually route you through to. So the first step in all of this is this very important chunk. This whole very important chunk where we're actually resolving the domain name of whatever service is internal to Facebook. So what they're saying then, that is another very important part of this, is this Border Gateway Protocol. So let's get into that because that's very important to this. To ensure reliable operation, our DNS servers disable these Border Gateway Protocol advertisements if they themselves cannot speak to our data centers, since this is an indication of an unhealthy network connection. Let me rewind just a little bit because the BGP thing is very, very important. BGP. What Border Gateway Protocol does is it basically advertises, and I'm a disclaimer, I am not a network engineer. I know about a lot of this from working at VMware, years ago, basically, and doing some vSphere stuff and blah, 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 all that good things. So what BGP gives you is a way to sort of advertise to the wider internet what this well-known DNS server's IP address is. Because the first thing you might ask yourself is, how do computers know about this well-known DNS server? similar. It's the same thing with Google's 8.8.8.8 domain name server. It uses this border gateway protocol. It's really the first step in making this a well-known DNS server. I'm sure some network engineers are going to drop in the comments and be like, blah, 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 blah. That's not right. Border gateway protocol, it's sending it out to the internet so that people can actually reach this and find it and get this domain name service resolution. All right. So to ensure reliable operation, our DNS servers disable these border gateway protocol advertisements if they themselves cannot speak to our data centers. Again, this is like enterprise grade networking 101. Since this is an indication of an unhealthy network connection, the recent outage of the entire backbone was removed from operation, making these locations declare themselves unhealthy and withdraw from these BGP advertisements. So what happened then is this entire backbone network goes down, down. And this data center, machine, well-known DNS stuff, it's looking to say, it's asking a question over here. It's saying, is network okay? And if the network itself is not okay, then it's gonna stop advertising. It's gonna stop advertising this as a well-known DNS server, which means then we can't get resolution from Facebook.com through the well-known DNS server all the way through to an actual IP address that would resolve to one of these data centers. And it sort of makes sense, right? Like you don't want to be advertising. You don't want to be advertising the wrong network over here, the wrong IP address to a data center or something over here, if your network is not healthy over here, because it probably just means that you have the wrong IP anyways. So it makes sense. So they stopped that advertisement. The end result was that our DNS servers became unreachable, even though they were still operational. This made it impossible for the rest of the internet to find our servers. That's very, very important. If they can't hit the DNS server, and then they can't hit these IP addresses resolved by the DNS server, then you're not hitting anything. You're not getting resolutions to any of this. And one of the things that I remember about when this outage happened was that you could go to like google.com and go to domains.google.com. Lord bless domains.google.com. What a great service. I'm so sad that they brought it down. But they actually were advertising, Instagram.com. Like you could buy Instagram.com. You could buy Facebook.com for, whatever money, which is insane, because it's not actually a domain that you could serve up, because it's all owned through ICANN by Facebook, or I guess Meta at the time. So it was kind of crazy. There were all these screenshots of being like, oh my God, I could buy Facebook.com, just because none of this was up. None of these servers, none of this domain name server stuff was up. It was all like, it had all disappeared off the internet, which is kind of insane. That's all the networking, and that's what is big about this statement, is that nothing was reachable. Nothing from their side, from their networking side, their DNS stuff was reachable. So we're really getting into the meat and potatoes now. All this happened very fast, as it will. This stuff will just be like a quick snap and it's all gone. And as our engineers worked to figure out what was happening and why, they faced two large obstacles. First, it was not possible to access our data centers through our normal means because their networks were down. And second, the total loss of DNS broke many of the internal tools we normally use to investigate and resolve outages like this. So two very big things there. One, access over the internet or access over their networks was not possible because they couldn't reach those virtual data centers over the internet, partly because their domain name service stuff was gone, and normal means of accessing that stuff, there was no route. Like, what am I going to do? I'm a Facebook engineer working remotely from my home. Like, I can't get in this way. Domain DNS is not resolving. The second thing that's also very important is that they had internal tools that maybe would fix some of these things automatically. Internal tools just break because the network is down and DNS no longer resolves. So maybe they had something like network I don't know, network health CLI tool or something that, maybe one of their network engineers could just run this. It's like, oh, it all works. But in order for maybe a tool like this to work, it needs some kind of DNS resolution from internal services that can actually make that happen. Our primary and out-of-band network access was down. So we sent engineers on site to the data centers to have them debug the issue and restart the systems. They physically had to go to those locations. So they were physically walking into these rooms to actually patch cable in to servers to the internal data center network to be able to debug issues and figure out what was going on. There's a scene from Mr. Robot where he's going to the data center to look at the physical hardware and stuff. I mean, they're at the data center being like, oh my God, things are broken. The network is down. How can we do this? Oh, I need to go physically to the location. And that stuff happens. When these big outages happen and there's no network for you to go through the internet or through an internal network to get to those machines, you get up and walk to those data centers. You physically go to those data centers. You send those people to the data centers. You send Mr. Engineer to the data center to actually look at what's going on. But this took some time, as it would, physically getting up and going to those locations, figuring this stuff out, because these facilities are designed with high levels of physical and system security in mind. That is another very important sentence. These physical data centers, you cannot just walk up into. They have some of the highest levels of security you can imagine. Why? Well, a lot of these physical data centers, may be the target of some threat actors, North Korea, Russia, China, etc. They are housing literal data it would be incredibly valuable to those threat actors, incredibly valuable. When I was at AWS, that was something that, could be deeply in the back of the mind of some of these people building new regions and new data centers and things is security. Security. You don't want somebody just to be able to walk up to your data center, walk right in, patch cable in and download a bunch of data or, upload some malicious code or viruses or something. The physical nature of these is of the highest paramount. So there was literal physical barriers to these people getting in. I don't know what it would have taken for Mr. Facebook engineer, Facebook person to actually badge in, get the authority and authenticity to be able to go into this location. They're hard to get into. Yes, they are, and they should be. And once you're inside, the hardware and routers are designed to be difficult to modify even when you have physical access to them. So even when you're there, even when you're on the inside, these physical data centers have mechanisms built into the physical hardware to make it difficult for you to just go in there and download data or upload a patch or something. This clip for Mr. Robot is great because they're like, oh, we gotta go to the actual location and stuff. It's a bit unrealistic because he kind of just walks in and then grabs a patch cable and just boop, beep boop bop and fixes it. No, it would be much more difficult to actually go about doing that, right? It took extra time to activate the secure access protocols needed to get people on site and able to work on the servers. Only then could we confirm the issue and bring our backbone back online. Once our backbone network connectivity was restored across our data center regions, everything came back up with it. But the problem was not over. We knew that flipping our services back on all at once could potentially cause a new round of crashes due to a surge in traffic. Individual data centers were reporting dips in power usage in the range of tens of megawatts, and suddenly reversing such a dip in power consumption could put everything from electrical systems to caches at risk. Okay, so there's a lot in there. What they're saying here is that each of these data centers reported lower wattage in each of those physical data centers. The physical wattage of the computer usage is down. Why? Because people are not getting routed, from their phone, looking on Instagram pictures of their ex or whatever. They're not getting routed over there. So these data centers are just not getting traffic. They don't have they don't have data to compute. There's no workloads getting to them. So all of a sudden, the total wattage is decreasing. Suddenly reversing that, flipping the switch back on to bring the networks back on and let people access services again, could cause a sudden, scary high surge of electricity to hit these data centers. So all of a sudden, you bring the network back online, and all of a sudden, you would get this huge increase in wattage, and that could potentially just take down caches, take down data, take down disks. Suddenly hitting a physical disk that has some database stuff on it with a load of wattage is a good way to destroy that disk. So obviously they don't want to do that. Obviously they're seeing the lower wattage usage and they're saying, oh, we shouldn't just bring everything back up suddenly. We need to roll out a solution slowly. Helpfully, this is an event we're well prepared for thanks to the storm drills we've been running for a long time now. In a storm exercise, we simulate a major system failure by taking a service, data center, or entire region offline, stress testing all the infrastructure and software involved. Experience from these drills gave us the confidence and experience to bring things back online and carefully manage the increasing load. In the end, our services came back up relatively quickly without any further system-wide failures. And while we've never previously run a storm that simulated our global backbone being taken offline, we'll certainly be looking for ways to simulate blah, 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 blah. Every failure like this. Okay, so that's the end of it, essentially. What the resolution probably was, they didn't go into too many of the details here, was rolling out a change slowly that wouldn't cause a sudden surge of traffic to hit any one data center at any one time. Probably one of the first things they brought back online was they probably brought on the entire network up so that the data centers could talk, so that we could start advertising the actual well-known IP of the DNS servers, but not the internet gateway. That's important. So don't bring on the internet gateway right away. Then they probably, this is my guess, again, they didn't actually provide any true details. They probably applied some configurations to the internet gateways to just trickle in traffic, or only allow a few of the regions to trickle in at one time. Because you don't want to just turn on the internet gateway and all of a sudden get this huge flood of traffic to every data center, blasting your routers, blasting your network again. You sort of need to ramp these things up slowly. So probably what they did is said, okay, we're only going to turn on the routing and the network between, Oregon and Europe initially, and then stuff in this region can flow this way and warm up both of these data centers, or just warm up the one data center, and then turn on, additional routing between these to warm up this data center. And then we can maybe turn on traffic that can warm up Europe all the way, and then, slowly sort of roll some of this out. Who knows what their actual protocols and things end up being, but that's my guess, is that you slowly roll something out via configurations, probably through the internet gateway or something, or even through the networks, or even at the router level, to allow for sort of a slow trickle in of network to let those things warm up. So that in short was the postmortem for the October 4th, 2021 outage, huge outage that Facebook had. I think it was almost an entire day, which is kind of crazy. And probably the biggest part of it was this physical server problem where they had to physically go into the server, into the data centers to actually fix things. Huge kudos to Meta for even publishing this, and giving us kind of a taste of what some of that infrastructure at Meta looks like. Amazing read. Absolutely fantastic. Very, very interesting.